Hi everyone. In this video, I will discuss about factors. Factors is one of the chapter in Cambridge syllabus, especially for A2 level. I will divide the factors into two parts. The first part is for the basic ordinary factors. We will see the factors in 2 and 3 dimensions. And the second part, we will talk about the application of factors. It's about the line equation, intersection points, parallel lines and perpendicular lines, and so on. So stay tuned and check this video out. We will start with the first one, part one, the basic normal factors. Maybe you guys know what is factors. Factors is a one quantity that has both magnitude and direction. Factor is a quantity that have direction as well as magnitude. Yeah, this definition differ between factors and scalar. While scalar only has magnitude, but factors has both direction and magnitude. So if we talk about direction, we talk about factor quantity. We can express factor in the x and y Cartesian. X and y Cartesian for 2-dimension vectors, and x and y, z, x, y, and z in 3-dimension problems. Before we start further, we have to know about the notation of the factor. If we have a position factor, we can express the factor in the bold lowercase letter. Factor A, factor position B, or we can express the factor in the form of arrow on the top of the name. So AB means factor connecting from A directing to B, from point A to point B. This is point A, this is point B. So if there is a factor from A to B, so we can call this as factor AB. We just can put the arrow or just put a line on the top. And then, how if we talk about the magnitude of a factor? A magnitude of a factor can be expressed as an absolute sign. So we can have the magnitude of a factor A, this, or the magnitude of the factor AB. What is the magnitude? The magnitude is the size of a factor, or just simply say it's the length of the factor. Yeah, the length of the factor. For example, magnitude of AB is 3. So that means this is the length of the factor. And then we can also express factors in column factor, because we express this in one column. This is for 2D problems, and this is 3D factors, x, y, and z. And then the last one, we can express the factor in IJK notation. What is IJK? We will see it later, but you can express this like xi plus yj and zk. If two factors PQ and RS, you can see the picture, have the same magnitude and direction, we can see that PQ and RS has the same direction and same magnitude, same length. So we can say that they are the same factor and parallel. But if they have different direction, we can say that they are parallel, equal in magnitude, but opposite direction. So they will satisfy this expression. We can put the negative in front of the factors. Negative here means the opposite direction. For two factors, those opposite each other, the magnitude still the same because magnitudes talk about the size, talk about the length. So in either direction, the magnitude, the length still the same. So AB, factor AB is equals to negative factor BA because they are opposite in direction, but the length of factor AB and factor BA are the same. That's about same and parallel factors. Now we move on into the factor calculus. So we have some calculations in factors. The first one is addition and subtraction factor. So the factor can be added or can be subtracted. We can use two methods to do this. The first one, using the factor geometry. We can add or subtract geometrically two factors or more by drawing it on a scale. How do we draw that? We have to put the factors at the end of the previous factors. So for example, if I have factor A and then I have factor B, so I have to put B at the end of A to perform A plus B. So I put, if you see, the factor B is starting from the end of factor A, and then the resultant factor is connecting from the beginning until the end of the factors. So the red one is the resultant. How about subtraction? For subtraction, we know that the subtraction is a negative sign. Negative means the opposite direction of a factor. So we can rewrite as factor A minus factor B as factor A plus the opposite of factor B. Yeah. And so if we have A here and another B here, the same example, negative B is the factor has the same length but in opposite direction. So A minus B equals to factor A plus opposite of factor B. So we have A plus negative B, and the resultant is from the beginning of factor A until the end of factor B, and this is the resultant. How about the length? Is it the same? Well, we cannot say about that. We have to do the calculation. So C and D in here is not the same, the value is not the same, the factor, the direction, you can see that it's not in the opposite direction, and the length is not the same. That's the first method, using the geometry. But using the geometry to find a factor resultant is very complicated because you have to draw it on scale. That's why now we move to the second method. We can use the algebra. This one can work for all types of problems without drawing it precisely. Factor algebra. So we usually express the factor in the form of column factor, or we just express it in the IJK notation. For example, I have two factors, A and B. Factor A is 2, 1, negative 1, and B is 1, 5, 2. The factor A plus factor B is just simply add the factors plus 1, 5, 2. Now, how do you add this? You can add by rows. So 2 plus 1 is 3. 1 plus 5 is 6. And negative 1 plus 2 is 1. So the resultant or the results of A plus B is 3, 6, 1. Second, P equals to negative 3, 2. Q equals to 2, negative 2. What is P minus 2Q? If we see here, we have a scalar or a number in front of factor Q. So let we write the factor first. So negative 3, 2 minus 2 times Q, 2 minus 2. Now, we have to multiply the Q first. So the 2 is multiplied to both numbers in factors Q. So it's negative 3, 2 minus 4 and negative 4. And this equals to, we can subtract by rows. Negative 3 minus 4 is negative 7. And 2 minus negative 4 is 6. So the factor resultant is negative 7, 6. 3. We have C, D, so find 2C and 2D. So we do the same thing. We can multiply the C first. 2I plus 3J minus 4K plus D. 3I minus 8J minus K. So we can add, or we can multiply first. We can 4I plus 6J minus 8K plus 3I minus 8J minus K. And then we can just add the corresponding term. I with I, J with J, and K with K. So it's 7I minus 2J minus 9K. This is the final answer. After subtraction and addition, we have multiplication with scalar. Scalar is just a constant, just a number. So like we did previously, 2 times 1, negative 2. So you multiply to both or to all numbers in the column factors. So it's 2 and negative 4. And the second example, 3 times, so we can 3 times 2, 3 times negative 2, and 3 times 1. So it's 6I minus 6J plus 3K. The implication is that if we can write one factor as a multiple of another factor, that means we can show that they are parallel factors. From the multiplication of scalar with a factor, we can say two factors are parallel if we can express one factor is scalar multiplication of another factor. For example, we have P is 2A plus B and Q is 8A plus 4B. So can we express this as a scalar multiplication? we can see from Q, Q can be rewrite as 4 times 2a plus b. Yeah, we factorize the 4 out the bracket, and then we can have 4 times 2a plus b. Now, 2a plus b is the same as p. So therefore, we can say Q is 4p. That's why we can say that factor Q is parallel to factor P, because we can express Q in a scalar multiplication to the factor P. Next one, position factor. What is position factor? Position factor is a factor directed from origin to a designated point. So from origin to any point, that's called position factor. It is notated by small single letter. For example, from O to A is a position factor A. From O to B is a position factor B. From O to P, it's a position factor P. So OA is factor A. OB is factor B. And OP is equals to factor P, position factor P. And also we can express this in the factor algebra. From the diagram, we can see that if we want to find AB, how do we find AB? From A to B. Using the geometric method. This is A, this is B, and this is O. From A to B, how do we find A to B? We can use A to the O first, and then O to B. So AB is AO plus OB. What is AO? We know that OA is A. So AO is negative A. OB is B. So B. So AB is equals to position factor B minus position factor A. Yeah, and this will apply for all direction factor. Yeah, we have to differ between the direction factor and position factor. AB is a direction factor. Because it's directing from A to B. Factor A is position factor. Yeah, direction factor can be AB or can be OA. So any 2 points, we call it direction factor. But any single small letter factor is a position factor. We have the exercise here. You can try this exercise. I will skip the exercise here. And then we move on to the magnitude of a factor. Again, magnitude is the size, is the length of the factor. So how do you find the magnitude of a factor? If we draw into D, from O to A. Coordinate A is 3, 4, for example. So that means it's 3 in X direction and 4 in Y direction. So I can say OA, vector OA is 3, 4. Now, the magnitude OA is the length of OA. So how do you find the length of OA? We can just simply use Pythagoras. So it's 3 squared plus 4 squared equals to square root of 25 equals to 5. The length, the magnitude of a factor OA in here is equals to 5. But from this example, you can see that the magnitude of a vector is a Pythagoras length from the x and y coordinates. So just do the Pythagoras. That's why the formula for finding the magnitude of a vector is just use the Pythagorean theorem. For 3D, you do the same thing. So it's square root of x squared plus y squared plus z squared. Let's see the example. We have P, 1, negative 2, and 2. So the magnitude of P is square root of 1 squared plus minus 2 squared plus 2 squared equals to square root of 9 equals to 3. And for the number 2, the same thing. 2 squared plus negative 1 squared plus negative 2 squared, which is the same thing, equals to 3. In this case, the length are the same, but the direction different. So the vector is different. That's about magnitude. Next, unit vector. What is unit vector? Unit vector is a vector that has magnitude of 1. It's a vector, it has direction, but magnitude of the vector is 1. All the vectors contain of unit vectors. For example, the vector OA here, OA. We say that the length of OA is equals to 5. That means this vector OA contains 5 of unit vectors. 1, 2, 3, 4, and 5. Because one unit vector has magnitude of 1. So that's why we call it unit vector, because it's a vector with the magnitude of 1. And the direction is follow the direction of OA. How do we get 5 unit vectors here? We divide it by the length. Yeah, kan? The length is 5. So that means there are 5 unit vectors. So how do we find the unit vector? So we just divide the vector. So what is vector OA? It's 3, 4. What is the unit vector OA? Now the notation of unit vector is like this. Is 1 over 5 of the vector OA. So the 5 here is the magnitude here. Yeah? The 5 here is the magnitude of the vector OA. That's why the formula to find the unit vector is 1 over magnitude A times vector A. That's a unit factor. Example, the same factor 1, 2, 2. What is the unit factor of A? So we know that the magnitude of A here is equals to 1 square plus 2 square plus 2 square equals to 3. So we know that there are 3 unit factors in the vectors of 1, 2, 2. So that means we just put the formula. So the unit factor is 1 over 3 times the factor 1, 2, 2. That's it. This is the unit factor. And the second example, the same thing. Find the magnitude of B, square root of 3 square plus 2 square minus 2 square equals to square root of 9. This is plus here. Plus 4 plus 4 equals to square root of 9 plus 8, 17. So the unit factor is 1 over square root of 17 times the factor 3i plus 2j minus 2k. Yeah, this is the unit factor. Next, move on to scalar product. Using a scalar product, we can determine the connection of two factors. Now, based on the name, scalar product will produce a scalar. It's not a vector, it's a scalar. So it's just a number without any direction. Let's see the figure here. I have two factors, A and B. They are combined, yeah, A and B, with angle between them theta. The definition of a scalar product is factor A dot factor B equals to magnitude A times magnitude B times cos angle between the two factors A and B. The point here, we call it dot. So sometimes scalar product is called by a dot product. It's called by dot product. For example, consider the two factors A and B shown in the figure below. Suppose A has modulus 4 units and B has a modulus, the magnitude 5 units, and the angle between them is 60 degrees as shown. By using the definition of a scalar product, we can find the scalar product of A and B equals to magnitude A times magnitude B times cos theta, angle between A and B. So it's 4 times 5 times cos 60 equals to 10. So you can see that 10 is a just number. So it's a scalar, not a factor. Some properties of the scalar product. First is commutativity and distributivity. Scalar product can be calculated commutatively. So let us check it. Using the same example, find the B dot A. B dot A is magnitude B times magnitude A cos theta. So 5 times 4 cos 60 equals to 10. So this result, the same with this result. So that's why we can say that A dot B equals to B dot A. So it's called commutative. And the other property is distributive over addition. So if we have A dot B plus C equals to A dot B plus A dot C. So it follows the distributive law. Yeah, it dot to it's of the term inside the bracket. Second, the scalar product of two perpendicular vectors. We know that two perpendicular vectors has angle 90 degrees. So A, B, and angle between them 90 degrees. So if we put into the definition of scalar product, we will have A times B times cos 90. Cos 90 is 0. So A dot B equals to 0. So that means if we have A dot B equals to 0, so we can say the two vectors are perpendicular or orthogonal. The dot product always equals to 0. Now, how do we find A dot B then? Previously, we always find A dot B from the definition of A dot B equals to magnitude A magnitude B cos theta. We always find the A dot B from the right part, the definition. But can we find the value of A dot B itself without finding the value from the right side? Yeah. Now, for example, I have A and B, these vectors. This is vector A, this is vector B. And then we can find A dot B is A1, B1 plus A2, B2 plus A3, B3. So from the example here, if I have A, 3i minus 2j plus 7k, and b equals to minus 5 plus 4j minus 3k, the A dot B is equals to 3 times minus 5, negative 2 times 4, and 7 times negative 3 equals to negative 44. Okay. Now, how do I get this formula? A dot B equals to A1B1 plus A2B2 plus A3B3. Is it correct? Okay, let's see. First, we have to know what are I, j, and k. I, j, and k are unit vectors in Cartesian diagram. So this is x direction, this is y direction, and k is the j direction. So the length is 1 unit, yeah, because unit vector. I is the unit vector of x direction, j unit vector of y direction, and k unit vector of z direction. So how do you prove A dot B? A dot B equals to A1 B1 plus A2 B2 plus A3 B3. Yeah, okay, we will prove this. So again, A is A I, A1 plus A2J plus A3K. B is B1I plus B2J plus B3K. A dot B is A1I plus A2J plus A3K dot B1I plus B2J plus B3K. Using the distributive law, so we can have A times B. So A1, B1, and then we will have I dot I. And then after that, times this, plus A1, B2, I dot J, plus A1, B3, I dot K, plus A2, B1, J dot I, plus A2, B2, J dot J, plus A2, B3, J dot K. And then the last one, A3, A3, B1, K dot I, plus A3, B2, K dot J, plus A3, B3, K dot K. Okay. Now, we have I dot I dot J, I dot K. Now, if we see from the formula and from the diagram, I dot I, what is I dot I? I dot I. So according to the definition of the scalar product, I dot I is the magnitude of I times magnitude of I cos theta. The theta between I and I is 0 because they are parallel, I and I. Cos 0 equals to 1. And magnitude of I is 1. So that's 1, this is 1, this is 1, cos 0 is 1. So I dot I is equals to 1. And that's analog to J dot J. This is J, magnitude J times magnitude J cos 0 equals to 1 as well. And K dot K is also equals to 1. So we know that this part will be equals to 1. J dot J is also equals to 1. And K dot K is also equals to 1. How about the others? I and J, I and K, J and K. Okay. How about I and J, I and... Okay, I and J. I write down here. I dot J is magnitude I, magnitude J, cos the angle between I and J, if you see, is right angle. So 90 degrees. Previously, if we have perpendicular vectors, the dot product or the scalar product is equals to 1 times 1 times 0 equals to 0. So I dot J equals to 0. I dot K, if you see, this is also right angle, I and K. So this will equals to 0 as well. How about J dot K? J and K, they are perpendicular also. So this equals to 0. So Ij, Ik, and Jk will be equals to 0. So this will be equals to 0. Ik equals to 0. And then Jk is also 0. And because they are commutative, so we can have J dot I is also 0. K dot I is also 0. And k dot j is also 0. So ji, we can cross this, ki cross, and then k dot j. So finally, we will have remaining a1 b1 times 1 plus a2 b2 times 1 plus a3 b3 times 1. Or we just simply a1 b1 plus a2 b2 plus a3 b3. So we have proven these expressions. So A dot B is the multiplication of the rows. Yeah. So A and B. Let us check again. So A 3 negative 2 7 dot negative 5 4 negative 3. So it's a multiplication of the rows. So negative 3 3 times negative 5 is equals to negative 15. And then 2 times 4 is negative 8. And 7 times negative 3 is negative 21. And is equals to negative 44, which is the same as this one. This is exercise. You can try also by yourself. And we can move on to using the scalar product to find the angle between two vectors. Before, we are using the scalar product to know that the two vectors are perpendicular or not, to find the dot product. And now we can use scalar product to find angle between the two vectors. We just need to rearrange the definition. The definition A dot B equals to magnitude A, magnitude B, cos theta. And then we can make cos theta as the subject. So we just rearrange the expression and we have cos theta equals to A dot B divided by magnitude A times magnitude B. Which just simply rearrange the expression. For example, we have vector A and B. Find the magnitude A. So magnitude A is square root of 4 square plus 3 square plus 7 square equals to square root of 16 plus 9 plus 49. Square root of 74. And B is square root of 2 square plus 5 square plus 4 square. So square root of 4 plus 25 plus 16. Square root of 45. So how do you find the angle? Cos theta is A dot B, magnitude A, and magnitude B. 437,254 divided by square root of 74, square root of 45. Equals to, multiply this, 8 plus 15 and plus 28. So this is equals to 51 square root 3330. This is cos theta. So theta is cos inverse 51 square root of 3330 equals to 27 27.897, 27.9 degree. This is the answer of the examples. Okay, let's move on to the factor in 3 dimensions, especially cross product. What is cross product? Before we have dot product or scalar product. Now we have cross product. So the definition of a cross product is magnitude A times magnitude B sine theta. The difference is now we use sine theta instead of cos theta. Now, the result of cross product is a vector, not a scalar. Yeah. For example, we have vector A and we have vector B, an angle between them. So we can find the cross product from A to B. So A cross B. A cross B definitely is a scalar. It's not a vector. But to make it a vector, we can multiply it by a vector. In this case, we can multiply it by a normal vector because we need a direction to perform as a vector. So that's why in here, when we have the A cross B, we need to multiply the definition with the normal vector n. So in this case, we can have that for A cross B is a perpendicular vector to A and B. And the direction is following a screwdriver in the right hand. So we use the right hand rule. This is from A to B, if you see. This is A and this is B. So this is from A to B. And the thumbs is up. So the direction is up. So from A to B, the direction is up. If we do in opposite way, B cross A, so it's from B to A. So the direction is downwards. So for B cross A, we have direction downwards. So that means in here, they are not commutative because B cross A is opposite of A cross B. See, you can see from these figures. A cross B is upwards, B cross A is downwards. They are not commutative, but they follow the distributive law. What happens if the two vectors are parallel? According to the definition, A cross B is magnitude A, magnitude B, sine theta times the normal direction, normal vector. Parallel vector has angle of 0 degree. So sine 0 is 0. So A cross B equals to 0, indicating parallel vectors. If you want to find the perpendicular vectors, you use the dot product or scalar product. But if you want to find the parallel vectors, we use the vector product or cross product. Again, the same. How do we find the A cross B? The formula is this. A2B3 minus A3B2I plus A3B1 minus A1B3J plus A1B2 minus A2B1K. Okay, this is how do you prove it? It takes a long time. So A cross B is A1I plus A2J plus A3K cross B1I plus B2J plus B3K. So that means A1 B1 I cross I plus A1 B2 I cross J plus A1 B3 I cross K plus A2 B1 J, this is J, cross I plus A2 B2 J cross J plus A3 A2 B3 J cross K plus A3 B1 K cross I plus A3 B2 K cross J plus A3 B3 K cross K. Okay, if you see again in here, now using the definition, I cross I is parallel. So equals to 0 because they are parallel. So the same with J cross J and K cross K. So we can cancel I cross I, J cross J, and K cross K. Now we try to find I cross J, I cross K, and J cross K. Now, we need the direction in here, yeah? So the direction facing to my face is X direction, yeah? I, and then J, and then for K is upwards. So I cross J. I cross J is equals to magnitude I, magnitude J, sine 90 degree equals to 1 times 1 times 1. So equals to 1. So I cross J is equals to 1. This is equals to 1. About the direction, I cross J. So this is I, this is J, and this is K. Using your right hand, so from I to J, your thumbs will be up. Your thumbs will be up. So it's positive K, the direction. How about I cross K? I cross K is also equals to 1. But the direction. Now, let's see I cross K. I cross K. I cross K is from here to here. So your 4 fingers from I is from to my face, and then cross K. So move it upwards. Move it upwards, and then your thumbs will be going to the left. So it's minus J times minus J, the direction. How about J cross I? J cross I is minus of I cross J. So this equals to -1. So this is -1. The direction is J cross K, of course, -K. Yeah, so this is -K. So how about J cross K? J cross K is from the right to top. So from right to top. And your thumbs will facing yourself. So it equals to I. And then K dot J is equals to -I. K cross I, of course, equals to J. Yeah, because I cross K is equals to -J. Okay, so we can simplify the answer. A1, B2, K minus A1, B3, J. Okay, we just rewrite first. Minus A2, B1, K plus A2, B3, I plus A3, B1, J minus A3, B2, I. And then we collect the I, J, and K. So it's A2, B3, I minus A3, B2, I. And then plus A3, B1, J minus A1, B3, J. And then plus A1, B2, K minus A2, B1, K. Or we can rewrite as A2, B3 minus A3, B2, I plus A3, B1 minus A1, B3, J plus A1, B2 minus A2, B1, K. Like this. So this is the same as the formula. This is how we prove the A cross B. And then to make it simple, we can rewrite the multiplication in the form of this. So we list all the A, factor A and factor B here, and then we find the determinant of the matrix. So how do you find this? When you find I, you cross I, and then you do the cross multiply. So A2, B3 minus B2, A3. So we have this. Now, to find J, so just cross J. So you have A1, A3, B1, B3, and then you do the same thing. A1, B3 minus B1, A3. Don't forget, the sign here will be positive, negative, positive. So plus, now find K, so cross the K. Yeah, we cross the K, and then so A1, B2 times, and then minus B1 times A2, like this. So this is how you find A cross B. Some applications of the factor products, of the cross products. I will discuss this first because this is not in the exam. So we can find a perpendicular vector. If we have vector A, and then we cross it with vector B, so we will have another vector C that perpendicular to both A and B. So A, B, and then it's perpendicular C. We will have that. The direction can be upwards or can be downwards, yeah? It depends on A cross B or B cross A. But they are perpendicular to both A and B. The second use of the vector product is to find the area of parallelogram. By finding the cross product, you will find the area of parallelogram constructed by the two vectors. This is also not in the exam, so I just give you information. How do you find the area of the triangle? So just divide by 2, because this is formula for finding the area of parallelogram. You can use the vector product to find the volume of a parallelepiped. So I will skip this. Okay, this is the end of the first part. Thank you and see you in the second part.